All right, so there it is. All right, so there we were. So there we were. The mic was turned on. I was standing in the front of the room, and I said, welcome to the June meeting of the Silicon Valley Fourth Interest Group. And for those of you that are on the interwebs, welcome to you as well. Thank you. So I was amused by the Dilbert cartoon this week. He's talking about his artificial intelligence, which consists, as near as I can tell, of an 8-inch piece of 2x4. So this is the time in the Dilbert world where Wally shows it to Dilbert, and Dilbert says, it looks like a block of wood, and Wally says, I'm only trying to copy the human mind, there's no reason to over-engineer it. And Dilbert says, I can respect that.
So there's a rumor to the effect that Bluetooth was named after some Viking or Norse or other one of those kings who was notorious for his inability to keep a secret.
Okay. I guess that's like many good rumors. That's partly true. Okay, rumors, gossip, innuendo, slander. Anyone? Okay. Without further ado, then, I will give you our next speaker. Oh, there'll be a little bit of ado while I bring up this PowerPoint slide. Take the mic. And take the pack.
Got it. Yeah.
Yeah, with a one.
That's a one.
That's a one. Really? It's an extra level of security.
Yeah.
Yeah, up those stations. The last one was 2. This one was 6 directions.
Okay.
Say who you are.
Hi, I'm Dave. So last month, I went to the Maker Faire. I've been to all the Maker Fairs. Sometimes I take pictures, sometimes not. This time I took pictures, so I'm going to show you what I took pictures of. So here I am waiting at the gate because it's important to get there early, so there's parking and you get to wait in line and talk to interesting people. So this is just inside the gate. Just has maps to everything. It's really important to get there early because the first hour is really not crowded. It's crowded from about 11 to 4. I mean, really crowded. So it's important to get there early. This is one of those fire sculptures. I don't think it was even on during the fair. So here's some of the things just inside the gate. Some of you may recognize the mouse trap. Yeah, this all looks like mousetrap stuff. Yeah. Really big bicycle. Yeah. If you fall off from this, you're going to get hurt. So this is a guy in a cardboard dinosaur suit walking around.
The pictures are my eyes. Off would be good.
Yeah, wait. I'll find it.
That way those of us that are inclined to
Yeah, better?
Yeah, much better. Thank you.
Okay.
Sorry to interrupt.
Okay. Just pieces of cardboard attached together. Looks pretty nice. So what this is a walking chariot. This is a guy here, and it has legs, and it actually moves / skates along. Pretty interesting. I've seen it there before.
It's a Dalek.
Dalek. So this is a, and he's working on his toilet, obviously.
He's getting a little aged.
Yeah. So
He's been through the wars.
so a Dalek is an example of assistive technology because, as you all know, there's actually a creature in here, but he needs this exoskeleton to move around. So.
Like many bosses that I've had,
Yeah. Okay.
and they use that same mantra.
Give him a name.
So this is the Lego pavilion for obvious reasons. This is one of the booths, and they were selling all the stuff. Oh, so this is a booth of a guy I met last year who has these really interesting walkers. And what's interesting about it is that it has the seat on it. So you're sort of half sitting on it, and there's a strap that goes around your waist that holds you in perfectly. So you can actually lift up both legs and have the walker support you. So it puts you in a really nice upright position while you're walking, and there's no fear of falling. Yeah. So he has a bunch of them that he sort of made in his garage. So yeah. Here's the close up. And this bright light here is an example of what concept? Yes, but it's actually retro reflective. So on these strips here, there's actually a bunch of miniature corners, reflective corners, and yeah. So the neat thing about these things is that any light that goes into it comes out at the same angle, same direction. So if you're taking a flash picture of it, this is what you get. Okay.
Much like a cat's eye.
Yeah. Ah.
Oh,
Yay.
Model 26.
And it's working. It works too. So yeah, it brings back a lot of memories because it has very specific smells and sounds and stuff like that. My first programming class, I was programmed on cards. There's a whole room maybe about half this big, just filled with these machines. And sometimes they jam up, sometimes the ink didn't work. It was a pain, but
I've used it at the Computer History Museum, and it feels so good when you push the button, the card slides in, you release, and it slides
Yeah.
out.
yeah, it was nice. So that was working. A couple of sols, S100, as you remember. So, Tektronix with a tape drive.
Is that a 4014?
I think that's in that same family with the display. It's like a storage scope.
I did a rasterized version of that where I had to write in all the command processing, line drawing, and assembly language.
And my
I was
memories,
programming the way men program.
my memories of these are a little blurry.
Yeah, so is the focus on it.
That's just a
Sorry about that.
just
And
teasing.
here's our old friend Dwight Elvey. He's doing good, except that he had sprained his wrist and he couldn't move that around too well.
That's the worst thing.
Yeah. S100 boards, that's a memory board, obviously, right? But it's not plugged in, so it's not going to work too well. TI-99 with a cartridge.
First 16-bit personal computer that had all 16 bits instead of 8 bits at a time.
Right.
It don't cost me total 5
No. So this is a little board, and I'm not sure what exactly it has on it to make it affordable and healthcare monitoring or whatever. But you can see,
Internet of Things.
yeah.
So where do you stick this board?
For a suggestion, or you can
I
put
don't-
it anywhere. It's got Bluetooth.
Yeah, I'm not sure it's,
On the left,
I'm not sure it's implantable though.
it's either Bluetooth or Wi-Fi. It's hard to tell.
It's probably have a SVIO Wi-Fi.
Looks like it's got both.
Blue mix, so it's Bluetooth.
But it's got two antennas there.
Well, somebody can look it up. Kinetic Care. Just another little board.
So that's for creating a USB device.
I'm not sure. I saw it was small and stuff, and I forgot exactly what its features were.
It's got an antenna connector. So
Wi-Fi.
some radio, some.
Oh, yeah.
It's not
Yeah.
any kind of sissy antenna connector either. That's an SMA.
Yeah.
A lot of them are used. Yeah, I know, but
Oh yeah, so this is the particle board, another small board, displayed in the same booth as the other one. Let's look this up. Okay. I knew Ting would get a kick out of this. How many I/O lines do you need to drive that? Yeah.
you just need one. You just have to shift them in really fast. Maybe two if you want a separate clock.
This is a, oh, looks like there's 3 panels, 3 color panels. I think this has been around for a while. Another Internet of Things. Again, I don't know a whole lot about these things other than it looks sort of interesting. So this is where Dwight and those, the card printer and the other machines, the SAL machines were. And I think Dwight is active with this organization.
Are these the guys that are bringing us the reincarnated
No,
vintage computer festival?
no, I don't think so.
Or Faire, or whatever they call it?
Yeah, it's a Vintage Computer Festival or Fair is in the, let's see, the first weekend of August at the Computer History Museum. So it's different management than in previous years. So, yeah, so be sure to check that out. This is a robotic hand, and you can see it's operated by cables to the fingertips. I'm not sure what pulls. I'm not sure what pulls on the cables though. Could be servos. So this is a little like exoskeleton thing across the shoulders and arms. And it uses, looks like there's a cable here to help move it. Yeah. Oh, this is a game for older adults with autism. And this is done by a team of 3 Stanford students. And they entered their project at the Rehab Engineering Conference that's coming up, and they're one of the 6 finalists. So they'll be going to Washington, D.C. in a couple of weeks. Right. So that's one of the people on the team, Nina, and Devika is the second person on the team.
It's called Me, Myself, and You.
Yep, MMY. Yeah, Nina. Another robotic hand. After a while, they don't get too exciting. Oh, this one has 4 sensitive resistors on the fingertips. This is for a platform for machine learning research towards improving myoelectric prosthesis control. But I don't know, it's still too much of a prototype. A lot of these student projects are just like one-off type things that never go beyond the prototype phase. It's got the whole world in its hand. Yeah. So one of the interesting things that I learned is that, remember how Maker Faire had this whole big pavilion where they sold all their little kits and books and stuff like that? So that's now all taken over by Barnes and Noble. So Barnes and Noble can be selling all that stuff. And so they have, I couldn't help but take a picture of this book because zombies are often a part of student projects in the Smart Products Design course. Yeah. So here's the, yeah. Here's the Barnes and Noble booth, and there's this electronics, ultrasonic transducer system hooked up here. I forgot what it actually did. Was it on? Yeah. Does that look like it's on a robot? I'm not sure.
No, all they need is a wheelchair. Just the eyes.
Yeah. Well, yeah.
All those robotic hand guys.
Yeah. So this is sort of an interesting project where you just put your finger over the sensor plate, and it picks up where your finger is. So they have it lighting up bunches of lights.
What kind of sensor is it?
I'm not sure. Could be,
Put
but
your finger over something, it's gonna
yeah,
you don't always have to touch it.
yeah. There's a pattern on that square there, but they're not infrared receivers or anything like that. That's sort of nice. And here's a keyboard made out of that stuff too. Talking clock and timer out of a single board computer. Just some booths in the main pavilion. Lots of arts and crafts there as well. So this is a dress made out of wrappers from candy wrappers. And I've also seen a bunch of dresses made out of duct tape and suits and stuff like that too. It does come in colors. I've seen some pretty interesting designs. Yeah. Oh, so this is actually I took this for Ting. This board up here is a oscilloscope interface. Yeah. So the neat thing is that you can put it on your board and have the circuit on it and have the scope interface right there.
Function generator, power supply.
Yeah. So that was pretty interesting. So I think this is a first robot. So I know they do things with basketballs and stuff like that. So, but there wasn't any competition there like in previous years. Yeah. Yeah. It's actually back on TV.
On cable or?
No, it's on regular TV. It was on like Channel 9 or something. Cable.
Wow.
So they had this whole pavilion, big tent, where this class did stuff like this, made things out of plastic and have balls running through it and stuff like that. So that was mildly interesting.
There's an annual Rube Goldberg machine contest.
Well, I'm not sure I'd call this necessarily Rube Goldberg, but yeah. Another one of these cardboard cutouts, and then here's Adam Savage coming in on the giraffe. Everybody knows that giraffe. Hey, that's a good picture. So, yeah. Yeah, I wonder what she looks like under all that makeup.
Sure that's me?
Yeah. This is sort of interesting. This is a cart that deposits letters in chalk dust on the sidewalk. Of course, there were so many people there that, you know, the printing didn't last very long.
Was going to be a big propaganda tool in June of 2001. I went to a rollout of a dot matrix putting anti-war messages on the streets, and then came 9/11 and a bunch of these projects. So,
Yeah.
pretty shock. Anything to do with being destroyed.
The rest of being or
Anything where people were voicing ideas that could possibly be through
Yeah. So this is a 3D printed prosthetic hand. This one here. And I think these work. I think the grip works when you flex your wrist, if you still happen to have your wrist. And as far as I can tell, this looks like a 3D printed brass knuckles, right? I don't know.
Yeah, that company, Lawrence's foundation, is doing pretty good stuff because it's based on your muscle articulation. It pulls like fishing line to plant fingers for third world countries where people get their hands blown off by
Mines and stuff. Yeah, there's quite a few companies that are doing stuff in this area.
The thing is, all these are open source.
Right.
So anywhere in the world that people have a 3D
Yeah.
printer, they can make it
Yeah.
themselves.
So in a couple of weeks, I'm giving a little workshop over at the Tech Museum. And the second half of the workshop is that the kids get to assemble these pre-printed robot hands. But as far as I can tell, they're pretty much just toys. You know, they're plastic, and I'm not sure how long they last. But all the pictures you see of kids, they have it, you know, upright like this. So I'm not sure how much functionality they have out of it. They get out of it, and if they indeed use it every day or not.
Yeah, they actually have videos.
Okay.
They've added those rubber fingertips on there.
Yeah.
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 And they're kind of ribbed, kind of like little chevrons.
Yep.
So that they can grasp.
Anti-slip. Oh, is this sideways? Oh, no. Oh, yeah, so this is a guy, his hand in one of them. And that's it. So, Kevin, where's Kevin? So one of the things that we can do here, subject to Kevin's approval, is play the first 17 minutes of the Adam Savage's presentation at Maker Faire, or we can keep that to later on. So, play? Okay. First 17. Well, that's it. Let me close this up.
So, what were at Maker Faire?
Yeah.
Your favorites?
Oh, God. My favorite part was going home because I was so tired.
I only found actually three things
Okay.
Cool. One was, there's a company that created a voice processing chip for Arduinos. It was awesome because you don't have to go to the cloud, you don't have to do anything. It's all built into the chip. So it does all you have to do is set the language up, all the command structures that you need in the Arduino interface, and then execute what those codes are based on the functions that you want to do. Like lights on, lights off.
Is this?
Yeah, you can set it.
It's voice recognition.
It's all voice recognition. It's awesome because it's all processing. It was a Kickstarter project that somebody did. And then the second really coolest thing was there was a guy that created an automated growing system using Raspberry Pi. So it had, water filtration, humidity, temperature sensor, all that. And it,
I guess the
it was all wireless.
link
I'll
to
get it.
Control and monitor the grow system.
you might have to search for it again.
Well,
It wasn't the link that I gave you because that's there it is.
and he was setting it up to scale. So now he could put them all together once he understood the flow rate, CFMs, or his pump that he bought to the tube size that he was using. This is he screwed up. He had too small of a tube, so he had a lot of back pressure and wasn't working right. He's got it right now, so he's doing prototyping, hoping to release it in probably by end of year. So it's all open source. Actually,
The freeze?
No, it's loading the page.
This guy created these little titanium spike bottom of a can, and you create your own little amp stove, which was pretty sweet because you can do is
Oh, you crashed shockwave somehow.
that you have like your camping, and it creates a nice little portable stove.
No, you have to restart the whole thing.
Well, I don't know
Okay.
how to reliably acetate
And it's strong.
my computer from the state that you left it in,
No,
because I
I
don't
didn't.
know what state it is, so
Yeah,
I figured it was safest to just start from
Okay.
scratch.
I didn't do anything other than
Well,
click.
it's
Yeah,
fine.
okay.
Don't stress.
Did you go to the maker? I saw a lot of the same, but I did see a big mega printing, 3D printer robot. That was pretty cool. Yeah, I mean, literally, it was several feet high. It could make images up to. It was fun. On cables. Yeah. 3 cables to the head. Mm-hmm.
Yeah.
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 It's very neat robot. Fast. Within 2 days, it built this big vase, multi-colors, and it was twisting. And it was perfect. It was pretty awesome. I've seen one of those using cement. Oh, yeah.
Could somebody?
John
John.
Harbaugh, could you open the door, please? Go downstairs and open the door. Thank you.
I think in China they have concrete, just a concrete printer, don't they? That prints buildings. Yeah. Yeah. And they're just
You just
really
seem so
cool
lively.
houses with, and they're vertical, right? But they're all spatially amazing.
Cross your fingers and
Because
hope.
it utilizes space so nicely in these pre-printed concrete houses. It's awesome. They were filming it, showing how they just.
If we want to stick to the schedule, maybe we can play that later.
All right. Thanks for your patience. Sorry.
Well, no worries, as you would say.
Super creative. Super creative.
Brad? Yeah. You are off.
We'll play the Adam Savage presentation at the end, okay?
And the link is on the schedule, so if you don't manage to satisfy your adversary's needs today, go home and satisfy yourself.
No, I'm good.
It's not supposed to do that, but yes, I understand. I had plans to back up this meeting on drives, swap the drive, and install Windows 10 on the other drive. We'll see how that works.
Warning you is that might happen before you're ready for it.
I am aware of that.
Just run this program.
Actually, a couple of them. I've actually sent links to these things to the mailing list. Mailing list. You've read all of my opinions about it, and I won't bore you any further with them.
All right.
Everything about frames.
Everything. Okay. All right.
Hey. All right, I'm Brad Nelson, and as usual, I will talk about putting pretty pictures on the screen. Well, the motivation for this talk is frequently the motivation for my talks, that graphics is fun. I like pretty pictures. But the sort of negative thing is that the graphic stack, especially these days, is a very deep and complex thing. And so, especially as I have only limited time to tinker about, I hope to keep things simple, and also I like things simple in general, so this is a challenge. For example, what do I mean? Well, on Linux, let's say you want to talk to X11. Well, you have your program, and then you have to decide what library you want to link against to do some graphics. Maybe you want to do xlib, maybe you want to do libxcb if you're new school. And then that talks over a socket, over a protocol or a domain socket, talks a complicated protocol. You can actually do the protocol by hand. I've actually played with that a little bit in Forth. It's not a trivial amount of Forth to just do the protocol directly. And then you talk to an X server. But from there, the story goes deeper. There's all sorts of different ways that the graphic stack can be set up on a contemporary Linux system. If you've got a Mesa OpenGL driver, then you've got your so then the X server can be one of these programs. Then it talks the OpenGL API, which is another complicated surface. It talks to the Mesa library, across to the gap, to the kernel, to libdrm, and from there it actually talks to the DRM, the DRI interface inside the kernel. It's the same story if you have a vendor-specific driver. You have your program, and it talks this complicated API, and it talks to a closed-source driver that does something, sends some kind of commands that you don't get to know about across to a vendor kernel driver. There's a new thing called Wayland. It's a different way of compositing all of this together. You have your program, you bind to another library, and it talks over a domain socket to another server that in turn talks into the kernel. All of which is to say that there are a lot of layers that you could choose to talk to, all of which tend to involve talking a protocol across the wire, using a library. And then inside of the kernel, there's several different ways of doing a driver that actually can display the stuff. There are KMS drivers, there's DRI, and then there's old-style FB device drivers. And I'm going to talk a little bit more about these later, because at least in the near term, this provides what I want. But of course, the FB drivers are considered deprecated, or at least there's a lot of noise being made about them being deprecated. And yet people continue to produce them because, strangely enough, being able to just do a direct frame buffer is fairly easy. talk about that more than a moment. Everybody seems to want low level. There's you know, this new standard called Vulkan that lets you program more directly on the device and talk to your graphics chip. There's a similar thing called Mantle. DirectX 12 has similar kinds of low-level leanings. There's a thing called Metal from Apple. All of them are sort of low level, but they're, you know, low level. Well, they're kind of low level. I mean, they're letting you specify things in terms of registers and values and whatnot. But there's a lot of layers to these things, and there's a lot of software involved. So, as you all know, this used to be easier. It used to be, you know, on an Apple II, you want to write to the screen, you get yourself in the right video mode, and you just write to memory. Or not so different on a CGA card or an EGA and VGA. You just need to know where to write. Maybe you have to poke some ports to do the right thing, but it wasn't so hard. So why is this so hard? Well, it's partially because we've actually got a separate GPU and they need to share memory. It's partially because people really want the last drop of performance, and so they want to do just-in-time compilation of operations that are actually touching memory. And people, you know, even back Apple II days, people would do this. They generate a little snippet of code to blitz something over, but that was an advanced technique. It wasn't sort of the minimal thing, and it certainly wasn't. It wasn't the default, and it certainly wasn't something that was baked into an API that you more or less had to use. Part of the problem is that what's really being done is that a lot of the code is involved as secret. The driver is a piece of proprietary software. You don't get to know what's in it. But the other aspect is that you're keeping the instruction set secret in some cases, and there are some good reasons to do this. I mean, one of them is portability. People don't want programs to depend on a particular kind of graphics hardware. But strangely enough, even the graphics vendors who you would think would have an interest in you being locked into their devices are not interested in sharing the instruction sets, because in some sense that's their secret sauce. That's, you know, what they have to offer, and so they want to put a piece of software between you and the actual instruction set of the device that you're running on. Another thing that I think makes it complicated is that because you've got OSs where you're sharing the screen, you need a layer in between that glues it all together and does compositing, because you want to have we've paid a huge price to have overlaid windows that can each separately have their nominally low-level thing drawing into them. And so compositing becomes a big part of this. And a big part of this is security. If you're sharing, you have to have boundaries between them. And so if you have a layer of software sitting between you and the actual hardware, that potentially means you can patch security flaws in the design of the hardware. You can use the software as a security barrier to say, okay, if the program doesn't validate, then it's not safe. All kinds of terrible things. So what's my real motivation? I should really, you know, I had this vague motivation up front. What am I really after here? Why am I bothering? My real motivation, or at least the physical prompting of it, is I'll have a Raspberry Pi, and I want to make some more interesting pictures with it than I've already done. I'd like to be able to have a fourth startup on it and have it do things, but I'm not sure that I want to completely swallow the problem of dealing with all of the I/O on the device directly. So maybe I want to have the Linux kernel and just talk to it. At least that was the thought. Yes. Well, so funny you should ask. When the Raspberry Pi first came out, it was not the case that there was enough information. In fact, they came out the gate with insufficient information to talk directly to the graphics device. Now, it happens that 2 years ago, Broadcom in their large ESC, I think it was for some particular event even, released a more detailed set of docs describing the internal architecture and instruction set of their GPU. And so it's actually the case that we do actually have a decent amount of information. However, it's a very complicated system. They didn't release any of the source code for their drivers, so they don't have a whole lot of code that gives you an example of that as to how you would actually do this in practice. And so the information is out there. There are people actively working on sort of bringing up larger and larger things directly on the hardware. But it's tricky, and it's a complicated dock. It's basically, they've got the internal processor. There's I think it's a set of 16 cores that are each doing a set of 4 instructions in parallel on a stream of stuff where each of them is operating on SIMD values. So there's a lot of parallelism, a lot of stuff you have to sort of orchestrate and set up to actually talk to the GPU directly, and you have to do this dance across, between CPU and GPU. So it's not out of the realm of possibility to explore, but it's very prohibitive because there isn't a lot of working code out there that you can look at. There's this one document that's it's relatively clear. It's a relatively concise doc for things in this day and age, and I think it's because they were trying to be transparent about how this particular system works. So I may go down that road if I have more cycles, but the thought was, before I go there, I probably want to have an ARM 4th that I'm happy with, and to do that, I probably need some kind of display capability. Ooh, and I should probably not get myself hung up here. I'll put that in the corner so it doesn't do that again. Oops, no, wrong corner. This corner. Come on. And back. Okay, here we go. So in any event, I thought, well, let's try to start keeping Linux around, but that's a tough slog. So there's this. I talked about all of those different approaches, but as it happens, there is this simpler kind of a driver that's available. It's the old frame buffer driver. And actually, weirdly enough, when Raspberry Pi first came out, because of this closed source issue, the only driver they had initially was a frame buffer driver. They're kind of frowned upon, and although it's one of these things where people on the kernel mailing list say, stop making these drivers, this is the old way, and people keep making them because they're relatively straightforward to make. There is a for the DRI stack that I mentioned before, there's nominally a process where you can also over that interface ask for a direct frame buffer, but it's very roundabout because those interfaces are designed to deal with the problem that because the CPU and GPU are sharing memory, suddenly what would have been just, let me switch modes, let me find out where the frame buffer is a conversation, a very noisy protocol about, I would like to allocate a chunk of memory for this purpose, I'd like to set something up, and it's all about being able to share the memory space between the CPU and the GPU. And so even getting a simple frame buffer is hard. And the other fun thing is that supporting a simple frame buffer is considered an optional feature for most DRI drivers. And so if you go and say, I would like to create a simple buffer for my particular display, a lot of the Linux systems that I've seen that don't have a frame buffer device, their DRI device also does not support a simple frame buffer. And so you can ask for a simple frame buffer, but it may say no. So lots of fun. So in any event, Raspberry Pi happens to have one of these simple drivers. So that's the path that I am going to explore. But I have a problem, which is that as it happens, this device is not the most pleasant to develop on all the time. It's something that I have to plug into an external display. It doesn't have I have an external keyboard that's nominally portable. It rolls up, but it's not something I carry with me everywhere. It's not something I can tinker on in the background. But then I come across an interesting problem, which is, yes. Okay.
Really cool 7-inch touchscreen.
Yes, there are devices that, yes,
I actually had to buy Maker Faire, which is great. It was only $60.
Oh, really? Okay.
No, it was a touchscreen.
Maybe I need to embrace development on the device.
And then I'll send they have a Raspberry Pi project where that 7-inch display with Raspberry Pi mount into a wall mount or desktop mount type system with access to yes, I'll send it. It's awesome.
I may need to embrace actually using the hardware device I'm thinking of using.
I was trying to write Python on it. I didn't want to see the screen, so I said, screw it, and it works great.
Huh. I think maybe you might have the right idea, because as I'll go into. But please do. Yes, indeed. No good. Okay. Well, in any event, having decided that this is a target device, and perhaps prematurely deciding that this was a target device and not one I would actively develop on, I thought, well, okay, surely I should be able to pretend on another system that I am talking to a frame buffer device. But as it turns out, this is something that's sort of not ergonomic. You can, of course, spin up an emulator, and you can emulate the whole system and boot one up. But if you simply want to talk to a device that looks like a frame buffer device, you're out of luck, as I discovered. And so I thought, well, let me see if I can engineer a solution to this, and I'll describe what I did in my sort of half solution, which is I'm not entirely pleased with, but it is a possible solution. So what I was wondering is, could I emulate the frame buffer device in a window so that I've got X Windows up and running, but I want to still be able to spin up a virtual frame buffer device. So what this, and I should say, by the way, that this is actually not, this is something that people have actually brought up over the last decade or more, and I'll go into the challenges around it, but it's something that sort of never gets settled to anybody's satisfaction, and in fact, I'm not really satisfied either, but we'll. So anyways, well, what's required? Well, what is it? So just a little more clarity. So the way this works is you have if you have one of these drivers baked into your kernel, you get a device under dev that's dev FB0 for your first display. And if you open this file, there's a very small set of things you can do with it. You can send a bunch of ioctls to it to query the device for mode setup. So you can figure out what mode you want to be in terms of display resolution and all of that, and then set the mode, and then and find out a little bit more about the device and be ready to go. And then you just write to the device, or you mmap it to get your frame buffer, and so you have sort of very direct access to the display. And so the ioctls, there's a very simple set of them. You can query for F screen info or fixed screen info. So you can ask about properties about the display that are fixed. And this tends to be basically the name of the device and a little bit of other information. And then you can get some dynamic information that you can either get or set. And this is stuff like modes. And so you can query, okay, what screen resolution am I in? What is the pixel? What format are the pixels in? What is the refresh rate? Things like that. And there is actually also some ioctls around vertical sync, and so you can also say, okay, I want to wait on this, wait for a vertical sync, so that you can time things well in terms of drawing frames. And the Raspberry Pi actually has a very flexible version of this. It's actually shockingly flexible. You can basically just tell it whatever resolution or vertical resolution you want. Now, it forces itself to square pixels. So basically, if you're whatever the bounding rectangle is of the format that you pick, it will force them to square pixels. But you can basically get whatever width you want, even very funny, strange widths, and down to incredibly small sizes. 80 by 80 pixels by 60 if you want. And then it sticks black sidebars. And then there's also a notion in this interface that you have the sort of visible region, and then you have a virtual region, and you can also basically lie to it about whatever virtual region. So you can have that 80 by 60 pixel area be mapped into some huge 1024 by 768 space. There's quite a range, up from 80 by 60 up to 1600 across. It supports a bunch of different pixel formats. There's actually an 8-bit palletized format, and then there's a 16-bit and a 24 and 32-bit. Apparently, when it first came out, there were actually bugs in the 24 and 32-bit pixel format in terms of the drivers, but apparently that's been sorted out. So lots of flexibility there, and I'll show that on the device. And then you just mmap it, and there you get your region in space. So you're taking the file and putting it into memory. You just get the address of the frame buffer bytes, which is exactly what I'm looking for. So how can I emulate this? Well, I went down the road of let's use something called Fuse. Fuse is this file system and user space, and it's a way to say I'm going to create a virtual file system that I'm going to implement as a program, and that will let me pretend to be a device and present this to my program. So you might ask, well, why? This is a lot of work to go to let your program talk to this device. And again, remember, my goal is that I'm trying to emulate what it's like when you're booted up on the bare system, up and with a full system, so that I can simulate things without shutting my system down into non-graphical mode or things like that. So this interface was originally intended to let you implement different kinds of virtual file systems. There's an SSH file system, so you can have a remote file system presented through this. There's a lot of, and there's actually multiple. There's actually support for this interface, not just on Linux, but there's an OS X and a Windows version of it as well. With varying quirks to them, and so people will use this to implement different kind. They'll use it to implement encryption layers, all sorts of different overlays on top of the file system. As it happens, there seems to have been a big flurry of activity from like about 2000 to 2011 around making Fuse better. And I think this relates to a number of things. People had some ideas about things they wanted to do that weren't supported in the kernel, like encryption and things of that nature. And I think there was just this big period of activity. So people were expanding this interface and trying to make it do as much as it possibly could. But somewhere around 2011, it seems to have died off. A lot of the interest in it petered out. There's a low-level and a high-level API. The high-level API actually came first, and it sort of operates at the level of individual paths, and then you're able to implement the different operations. So you implement open and read and write. The low-level API has a notion of tracking individual inodes, and it actually gives you a little bit more context when you're implementing a file system. Depending on the style of your file system, one or the other can be easier. The other nice thing about the low-level one is that it's capable of coping with there being multiple coexisting file systems in the same process, whereas the high-level API kind of assumes a bunch of things are global. So the thing about Fuse in terms of mmap, though, is that you can use mmap on a Fuse file system, which would let you emulate this frame buffer layer. But unfortunately, it requires an operation called msync. So normally on a Linux system, if you map the frame buffer, you get this region of memory, and you just write bytes in, and they show up on the screen immediately. But strictly speaking, when you memory map a file, the strict sort of POSIX spec says that you need to do an msync to guarantee that what you have written into memory will actually show up on disk. And because mmap is marshaling all of this back and forth through the kernel as writes, you actually have to do this msync operation if you're implementing something with Fuse. Now, funnily enough, they're actually back in that 2011 period, there were folks that were proposing almost explicitly for this purpose support for other ways in which you could do the mapping, where you could map a shared memory region, all kinds of things like that. But unfortunately, although there are a bunch of outstanding changes to the kernel, none of it ever made in. There's a bunch of sort of half-finished, here's a change, Linus Torvald says something, and then that's the last you hear of it. The other thing is that only towards the end of that period did they actually end up supporting ioctals. And the thing about ioctals is there's sort of two kinds. An ioctal, sorry for context, is a system call that you can do on a file that is basically it's the escape hatch to let you send arbitrary kinds of file system specific messages. And there's two kinds of ioctals. There's ones where the ID of the ioctal has baked into it a size field that indicates how big the payload is that you're going to send over to the kernel. And then there are ioctals where they're variable length. And unfortunately, for reasons I cannot fathom, it may just be history, the frame buffer ioctals happen to be variable length ones, not fixed length ones. And so the ioctal number does not imply directly how big of a buffer to send over to the kernel. And so while you can receive these ioctals, and you get the address of like, here in the user's process is a buffer that contains the information you want, you don't actually get the data. You get the address of another process. Which there's ways potentially around that, which I'll talk about in a moment, but that's a very unpleasant and unfortunate thing. If it had been almost any other, the vast majority of ioctals have their size baked in. My guess is that it's because this is a fairly large field, and maybe when they, yeah, I don't actually know. It's a good question why. So how this works is that you run your Fuse program over here, or sorry, you run your Fuse program over here. It talks through to the kernel to implement a file system, and then exposes it in some path that where you've mounted that file system, and then you can access things in it. And so it stays alive for as long as your process does. There's another interface called queues, which is a character buffer interface. This is a layer that towards the end of that flurry of activity around this in the kernel, this was another path people were going where they wanted to support implementing a character device. And so this interface is actually in the kernel. It's still there, but it was kind of an it was like there was this frantic push, and then sort of interest died off. And so character device, it actually lets you do variable ioctals. They decided, hey, let's support this. This is a thing because a lot of the character type devices end up needing these things. And so there's this interaction where you actually had to do this sort of little dance where you say, it says here, you got an ioctal. How big is it? And then you reply and say, okay, let me go and get that many bytes for you. And then you sort of a fairly chatty protocol, but you actually get back the result. One quirk of that, though, is it requires elevated privileges because you can potentially say, oh, I want this really big area, and then you can access the other process. So you need higher privileges to mount these, unfortunately. But the real problem is that it doesn't emulate mmap. So, so each of these two interfaces provides approximately half what I would need to do this perfectly or nearly perfectly, and neither of them is quite right. And remember, mmap still needed that msync. There's a way that this could conceivably be done, but this is a lot more work. There's an interface called ptrace that lets you monitor a process that it needs to be one of your child processes or one that you've got permissions to touch, and then you can intercept all of the system calls in it. And this is what's used to implement things like GDB, so or also the Chrome sandbox. You can intercept all of the messages going in and out, and you can also reach into that process's memory and inspect it. So you could imagine having either a fused file system or maybe even not. You could maybe do all of this through ptrace, intercept all of the appropriate calls, realize, okay, they're going to be they're doing this ioctal, and now I need to go and reach in and grab out the chunk of memory that I need to respond to the ioctal. Could be done. It would be an awful lot of work. It's a fairly complicated and subtle interface. But it at least highlights in my mind the possibility that this could be done fairly close to right. You probably could even get the memory mapping to work right if you intercepted the memory map call and then you instead imposed some shared memory and then superimposed this somewhere that you can reference. So it could be done, but that path is very tricky. So what did I actually do? So I put up I made a very simple program. I've called it virtual frame buffer win. I used Fuse to provide the frame buffer because that at least did that mmap interface that I was interested in having. And then I implemented just popping up a window on OS X and on X11 to provide a window for the frame buffer. And I just baked in a size of 1024 by 768 at 32-bit for now. And I just punted on the ioctals. And the reason I figured I could punt on the ioctals is that in practice, when you have a Raspberry Pi, there's only a couple of modes you're interested in. Your application probably runs for its entire lifetime with a single mode. And so if you just ignored all the ioctals, as long as you had as long as you have the right assumptions and the program has the right assumptions, you're fine. There is an issue around vsync, but basically and you still have to do the msync, but doing the msync is essentially a no-op Raspberry Pi. So if I had a program written to do the msync, that's fine. There is still an issue about catching that vsync, which if I were to care, I suppose there might be, I could have the ioctal I could ignore the fact that I don't actually see the data field for the vsync ioctal and just have it pause and respond if I wanted to do that. One reason I didn't do that is that the version of the Fuse interface that is supported on the Mac was a little, basically stopped making progress a little further back in time than the point in time when they added the ioctals. And so some of this is sort of, sort of frozen in amber in terms of the capabilities of these interfaces. So I settled on what I could, the intersection of what I could do on both Mac and X11. So the net result is, from the point of view of a fourth program running in these kinds of constraints, you could allocate a buffer as just a chunk of memory. You could plot a point by just writing data into it, and you can, and then just open up that file, and then if you want to flip a frame over, you just write it across the gap. Or if you wanted to be fancier, you can mmap it, and there's pros and cons to that. So now that's the end of the slides, but I'm going to go to a demo and talk about some more subtleties with it. So the hope is that I'll be able to build on this to do some interesting things longer term, running directly on the system. But let's hope that the. Oh, is this not actually powered? That's not powered either. Dave, is there a button? You had power. Let's see. There's power. These don't seem to be. Is there a button to push? Nope. Thank you, Kevin.
It's going to help because I can't see another place to plug it in other than here.
Oh, what the heck? That's weird. Hope I have a demo list here unless I've got.
Just not like that.
Ooh, that's interesting. Maybe did I grab the wrong?
Do you need some more USB juice? Spot holes?
Yeah. What's? Oh wait a minute. Maybe I'm plugging it in the wrong. No. Let's see.
Like this work?
Might that might
Oh,
indeed.
you want USB to USB? Oh crap! It take juice from that.
Well, actually, I might be able to. Let's see.
It's sucking.
No. Something lit up.
Let's call it a win.
We'll see if it comes up. I should have. Actually, the other possible. Oh, I didn't bring a cable for the. Do we have the? No, we don't have the HDMI. Well, if that doesn't. In any event, in the meantime, let's do the other half of it on here. I don't know if that's actually coming up. Something's here. Let me take the lid off of this.
The 2-amp one or the other?
So in any event, here's my. Let's see. Could be that I grabbed the wrong. Well, that too.
You have a USB B, or which model do you have?
This is the B. Yeah.
Here, you can use this. This should provide enough power.
Oh, okay. What is that?
So you'd have to.
Oh, we
use
have to. His. Okay. Let's try that. Let me see if we get any better luck. Okay, something's lighting up there. Let me actually see if we get. The other thing is maybe I need to. Oh, that's. The other thing is it may be that we need to. I'm trying to remember. I've had this thing actually hooked up here once before, but there's an HDMI plug there, but I don't know if I. Let me see if I brought.
But you're converting, so it should.
Yeah. Should be.
You got your HDMI converter, right?
I have an HDMI cable, but there was one here at one point.
Oh.
I've got one too. Let me see what I've got.
You had one on your desk, right? It was in that plastic bag?
Yeah, it says HDMI and DVI adapter.
Well, you guys sort that through. I'm gonna plug this here to. Ah, cool. Into the wall there.
Yeah, I'm going to hand it to you, and you're going to take it and stick it, as they say.
All right.
Is it the right kind?
It seemed one of those in little loops actually.
Make sure that's not a display cable.
Oh wait,
Oh,
is
it's a display.
No, that's HDMI. Let's see.
It's just not going to say what you expect it to say.
Video?
Yeah. Try video, that might do it. There's video, iPod, auto image, warp drive. Let's just press things at random until something works. No. I think just press the video button and leave it. I think that auto button is probably a bad idea.
Let's see, maybe
Anything that's automatic is probably.
trying the other. Actually, I didn't realize it was lighting up inside when I had the other power source. So. Okay. Demo fail. Awesome.
We love that.
Yeah. Well, in any event, let's. I can actually. The whole point of this exercise was actually to show you the. We can actually switch over. Is it which one to get back to the other display? Laptop one. Okay. Well, in any event, the whole point of the exercise was the virtual aspect of it, which, as you can see, the Raspberry Pi is proving fickle. So my application here consists of so I'm going to build it here, and it's up on GitHub. You can check it out. And there's a couple things I'm building here. So the application is just this one standalone executable, VFB-Win. And then I've got a few samples that are some C programs, and then also Forth programs that do the same thing. And actually, doing the demo on here is probably for the best, because so the way it works is if you run this program, and it works the same on X11. You started. Whoops. Oh yeah, you have to make a directory for it to mount into. Actually, let me open one other. Okay. So you'll see here I have this directory called dev that's empty, and I'm going to run FBFBWin, VFBWin, and I've not currently mounted. That's weird. Okay. So yeah. So this window has popped up, and if we now look in this dev directory, there's now a file in there, and so programs that know to open that file and write to it. For instance, I can let's see, if I actually go in there and do, if I cat dev urandom to that file, then it will read from the random device and just fill that this one with random contents. Or similarly, if I take there's a dev 0 that just a device that just returns zeros, and that will fill it with black. So so let's see. So I have a couple different programs here. So I have to start out, like this pattern Forth file. All it does is actually, much like from the text from the slides, I allocate a frame buffer. I have a plot function. I have a flip function, and then I just have a loop here that goes through and plots a pattern. And the pattern I'm plotting is just the x coordinate times the y coordinate plus an offset, and then I move that over each frame. And so if I run that Forth program, then I'll get something like that. Yay! And so that's nice little test pattern. Kill that. Now the one thing I was interested in exploring is the relative performance versus a C program, because one of the things I've been pondering is that, so here I'm using GForth, and for doing lots of rapid pixel calculations, it's not the fastest Forth. So one of the things I'm imagining doing is maybe doing an ARM Forth that's a little more performant, and I want to have some idea of what the performance gap currently is. So I have the same kind of program written in C, does the same thing, but there's a couple of differences. One is in the C program. In GForth, it is possible to do an mmap as well, but you have to go out and what it actually does underneath, if you use any of the system calls, is that it goes and compiles a small C program to dynamically link in. And so the setup for that is a little tedious actually on the Raspberry Pi, and so I wanted to keep it in the Forth program just doing writes. But the C program I do both mmap, and for a standalone ARM Forth, I would be able to just do the raw syscall, so that'll be much nicer. But in any event, I can run. So here's the version that does just a wrong one. It does just the write. As you can see, whoops! It currently I have it set up so that it rather inconveniently exits if you click on it. So it's moving a little bit faster. And if you do, and this actually is even more apparent when you do it on the device. And if you do the mmap, there's no visible difference on here, But on the actual Raspberry Pi, there's a noticeable difference in performance because it's skipping having to go through the kernel for each of those writes. And then I also took and converted my my favorite haiku, that 4-spire haiku, which actually I can bring up the original. And I actually learned one thing in the process of this. So this is, as many you'll see, I'm be familiar with this particular image as I frequently use it, but this is one of my first sort of vaguely interesting haikus. And I realized something I had never noticed before, having, I guess, not analyzed the program much, but that it's actually wasteful, and it's actually very close to being something that I can do. It's actually doing the same x times 23 sine divided by 2 max. As that value, I can actually whittle it down. I can actually whittle it down to a true haiku. So, in any event, and I noticed this only when I was. I didn't actually notice it in the 4th program, but I noticed it when I tried to convert it to C, and was thinking to myself, "Wait, I can make this program a little bit simpler." And so, in any event, I have a version of that that's just in standard form. See the haiku sitting right here. It's a little more verbose, you know, with float words, but you can do the same thing, and then it does this. And you'll notice it's creeping along ever so slowly as it redraws. And that's now in comparison the C program. Oops. And there's actually, okay, so I'll do the right version first. And actually, there's not, you'll notice it's creeping along a little bit faster. The mmap one, I think, is, I don't know if it's actually, yeah. So on the device, the mmap one is, again, noticeably faster because it's skipping an extra copy of the writes through the kernel. So the other thing I discovered, and we'll not be able to demonstrate that given my demo fail, is that this program for this haiku, be it, so in 4th, it's immensely slow. Even in C on the Raspberry Pi, it's terrible. It's much slower than even this. And the issue is that just the sheer computational capabilities of the CPU are dramatically smaller. So my guess is if I want anything like this to display quickly, to do this, you know, live, that I'm going to have to either write directly to that GPU or I'll be out of luck. Especially when I consider that, you know, if I take something like, you know, well, here we'll go back to the you know, it's in my in this in the haiku editor, I can, you know, I can add the animation in the same way. Let's do T is T plus something like that, and then whoops, that's not right. T, oh no, the other way around. X is X T plus. And let's do that a little slower. Let's do T 100 mod. And it's just zipping along there, and obviously by and I can make it bigger. Whoops. Need a better interface from. I have this pattern to add to the URL that makes it bigger, but it's not as fast as it should be. I'm just going to do. I actually put a little mod in here because the plus wraps around too fast for you to see, but it's you know, orders of magnitude faster and more flexible. So in any event, long way to go to get that there. I'm not sure if this pattern of preparing the application ahead with the frame buffer device will actually be all that useful. But it's an interesting. It gave me some interesting insights into what's sort of missing. It's surprising how hard it is to make virtual devices. And when I down to do this, I thought, well, you know, maybe I'll emulate the frame buffer device, and maybe I'll go and emulate one of the DRI drivers, and actually, you know, emulate the behavioral hardware. But it's just the fuse and Q's interfaces are almost there, but not quite. They don't have They have all these weird quirks. The different versions of them have. It took me quite a while to get just the shutdown behavior of a Fuse application is very erratic. A lot of them are designed for you install like an encryption mount and then you leave it running for the life of your system. And so the shutdown behavior, if you're bringing it up and down, is it tends to have lots of quirks. Anything goes wrong and it leaves behind stale stuff that you have to run stuff with sudo to make go away. So in the event, questions? I left you all in stunned silence. And I like your suggestion of actually working on the device, because emulation is not all it's cracked up to be.
Would it be reasonable at some point in the far distant future to build a device that's a standalone haiku kiosk that has a Raspberry Pi, a nice display?
Well, so with the performance I'm currently getting, not likely, but yes, that would be yes.
Figure this out. Like we had to use. Like you have a video game console made out of plywood. Calls to mind, you know, an early day arcade game. Instead of having an arcade game, you have a keyboard. Type in a little haiku.
Indeed, yeah.
It shows up on the screen.
I have the same image as well. Someday for Maker Faire. Yes.
Is that a thing, or is
I no, I actually kind of I see the vision, and I admit that that's something that I think would be a good demo for Maker Faire if I could muster the effort. I'm not sure what the right piece is. Just
teaching people enough to write a haiku with Maker Faire might be.
That might be over the top. Yeah.
Maybe just to have the thing there and show it. And having it flip through haikus. And you have over here maybe a laptop or something. And somebody gets really interested and is excited. How's this? What is this?
Right.
Take them over to the side and say, okay, here's this, here's that.
Right.
This is how it works.
Well, we certainly. It's the makings of. Good question. It's like with all the submissions that we get, we certainly have the makings of a, you know, an interesting art display, if nothing else, right? It's like people come by, they probably just sit there and stare at these for. That was, what was that one? What is? Oh, that one's neat.
Displays bacteria. It's like hypercorrection in action.
Wow.
Yeah.
But you could at least let someone tweak the constants, even if they're not a fourth programmer, and see what happens.
Yeah, it's a. Yeah, no, I definitely share the vision. I should definitely think about what it would take to get it there. I fear that the Raspberry Pi as a platform just doesn't have the horsepower without a lot of value added. Yeah.
I'm just hoping not to have to bring the internet.
Yeah, no, that's Kevin's point about not bringing the internet in is probably. But yeah, no, the 3 has substantially more. And I believe the 3 has a better set of drivers as well for the X window system. The 2, I think they never quite got the drivers or the 2B or 1B or whatever the 2B guy. Oh, sorry, which?
It's sort of a shame that it's don't have better access, because I can do a media streamer on my Raspberry Pi 2. Works perfectly fine.
Okay.
And that's full motion video. So, well, that's a different load.
Yeah.
Well, it's definitely taking a more optimized path through the software. Well, actually, if you mimic, so what's it called, Brett? Software. You know,
If you go to SVFIG talks.
it used to be XBMC, which is now
I don't see it at GitHub.
So, Go to repository. Oh boy, that's actually, it's getting hard to find. I'm sorry. It used to be towards the top. I need a better link in there. If you go to, there we go. And then if you go,
Okay, so what I'm gonna do is
actually,
just cut
scroll,
paste
scroll,
from
actually, there's a
there.
better link there. Go down. Scroll down. Yeah. There. That'll be the link. There you go. You can get all the. Yeah, that really doesn't want to come.
Before I started programming on Raspberry Pi was my media center. Yeah, I've got my still set up as I'm just not using it as a media center because we
hear us, Bob? Can you hear us? Do we have a thumbs up from you?
Maybe he has to unmute on his.
You may need to unmute on
Yeah,
your
hello?
end. There you are. But
I just
now we
unmuted
have
my
to have
mic.
volume. Hear us, Bob? Can you hear us?
Yeah, but there also has been, just recently, there's been a bunch of staticky noise.
You may need to unmute on your end.
Wait, I gotta
Can you
turn you
say
up.
something? That's not helping. Okay.
Yeah. There's been a bunch of staticky noise. I don't know what the static is. Oh, man, I gotta turn off something.
Once you're volume for that device.
I have feedback. And I didn't think about that.
That's connection.
Let's see if I got some earbuds here.
So he's talking with you.
Yes.
Yes, he is talking. So we are getting that there.
Yeah, it doesn't seem.
So it says headset. Maybe the sound device.
Headphones.
This is really slow. Maybe that's what I need to do. Am I still?
Is
Hello? Got the screen up. Wow. Put it up with sound. Can I turn off the sound? Not have this. Oh. Hello?
hey, okay, I'm
Wait.
hearing you here. I'm hearing you on a my headset, so that means that it's the internal okay, so it's that system. Hang on, we're getting there.
Well, is it a feedback problem? Am I?
And what we
I'm seeing different things.
ah, there we go. Correct. Correct.
We're almost on match.
Say something, Bob. Talk.
Say hi.
Can you
Hello?
there we go. There we go.
Hello?
There we go. Yes.
Oh, are we getting somewhere? Ah.
Yes.
Can you hear me?
Yes. Yes.
Can you hear me?
Lights down.
Hello? Hello?
How do I turn lights off?
You hear me?
Oh, that's
Nobody hears me.
there we go.
Hello?
Yes, we can hear you.
Oh, great. Okay, great. Wow. We're getting there. Yeah, that static was worrisome.
It's getting there. It's slow.
Hey. Well, are you saying something? I hope not. Say something.
Hello, hello, hello.
Oh, okay. Because this is, we got a delay. Yeah. I don't know. Okay. let me, I guess, try sharing my screen here, which, oh, actually, I know what I need to do. I am sharing. Let's see. If I go, oh no, that's not what I want to do. I do want to. I don't understand where well, the bottom line, let me go to here. Let's try that. Share that and see. Well, this is my personal cozy. Are you seeing that?
Yes.
Yeah. Let me hit F11. Actually, I want to get over and I'll hit Control S to do a save on that. But where I really want to go, oh, hey, this seems to be working. Is it readable for you? Is the screen readable?
Sort of. As good as our resolution is.
Oh, well, let me, well, that's one of the things is, let me go. One of these things that's just made much simpler is the editing of things. So I've started keeping things in a script here. And this, when I restart, will go and actually my notes here sort of say I should make this 270 and 80. We'll leave that. But one of the things is, I mean, this is setting in this script, which will get loaded when I redo it. Well, in any case, I'm hitting Control S in this script window right now, and that just saved everything. And now I'm going to come down here and buy, and let me go and find, yeah, here, and restart. And okay, I've changed the font. And actually it came up, and when you this is one of the things is it's the amount that I don't know is astounding, because I've just followed a path to get things done. So I really don't know C and Unix or, you know, even Windows very well. Oh, what I wanted to do, and this is a question that I have. I've just gone to the directory that all of the stuff is in, is you know, is open, and so you can just download it. When you download it, you should just download it into a directory called Forth, and then just execute the bat function, and you should end up essentially on a screen that looks like had F1. Okay, so but that's, I mean, yeah, it's busy. Don't expect you know, empty screens, but then again, I see the stuff that you guys look at all the time. So in any case, I think maybe since I've gotten to this point, we can get back to what I've been doing recently. And then one of the things I really want to go and make this two-way, because like I say, I don't even know what a good method is, whether it really is useful to put a zip file up and put more zip files up, or just put the damn things up there, much less use a GitHub or something like that. Anyway, let me go and follow my instructions. First lesson on a blank line below. Tap F12. Okay, tapping F12. Tap Enter. Tap F11. Now it may seem, and then tap Control S. Okay. It may seem that that is ridiculously trivial, but at the same time, that's the highest value. And again, I mean, just time is pervasive. So the whole thing is having, you know, this is my log. And let me come down here to actually today's notes and hit a timestamp, and we're talking. But one of the things that let's see, you notice that I actually make notes in it, and oh, yeah, one of the things, all this stuff about what graphics used to be. This was 1984 on a Sage 68,000 based computer that had the APL created by Phil Van Cleef, and it had true bitmaps. So that.
Oh, there we go.
Uh-oh.
There we go. Now, Bob, you're stuck on just one screen there. You may have
Oh,
to
it's
share
not
your screen to green. It's not updating at
Oh,
all.
damn. Well, oh, wow. Wow, that's what we need, the feedback.
Lost our audio for a minute.
You'd better start over.
You might want to tell them to share
Oh.
the entire screen. There's not, when you have share screen,
Right.
pick the one.
You may want to share the entire screen.
I thought, oh, you know, it looked to me like I had. So,
Yeah, it looks like you were sharing a window and then closed the window and it was just stuck.
oh, damn. Well, I wish the feedback. I need feedback. Okay.
Yes, and our mic disconnected for a bit. So we're back to you.
No, I'm looking at you, so that should be right. And if I go to here.
There we go. There's the window.
Oh, man. So you'll have, oh, geez. Well, consider it was the radio age, you know, I don't know. That's not going to go back on that, you know. But one of the, yeah, this gets to, these are my notes that I've taken so far. Those can be filled in, but one of the things, as commenting, this I made in 1984 on a Sage 2, which was one of the whole mess of 32-bit of 68,000 computers around before Mac screwed up everything, or an IBM. But this was an APL by Phil Van Cleef, and that's actually a bitmap. Everything, including, I mean, you know, except for I ran it off on regular paper, but everything except the, you know, the characters, everything is totally bitmap, and that was the age of simplicity that, in some ways, I covet. Oh, and with respect to that, all copies of you know, my 6-cube logo. Let me, oh, I guess I don't want to see it. Well, there, you know, there it is. But there's one behind me, if you can see me. I guess not right now. In any case, literally all of them, including the big blow up, are from Electronics 4010, which was the only, and of course that used used vector input, but then managed to store it on storage screen, and then managed to read those voltages off of there. Anyway, up to the present. I was saying that when you download it, this is what you'll see, and I went through the process of putting down a timestamp, but you can figure that it's all just text, except as you'll notice, F6. If I have the line on on a line that is understandable and produces a cozy result, I can just hit F6 and it'll do it. And I see that my first instruction thing here is R and row. Row is old APL for the count of an object, how many items there are. And R is actually the root dictionary, which you'll see everything else. And it's just a pair of lists of well, and here is actually R, the dictionary, and then, well, tick, row, so that's the row function, and then tick M is monadic each. So it's what's, oh, and then you can see it's a pair of 31 element vectors, lists. And actually, D names gives you, that's essentially the same as R, well, oops, 0. I've got to convert this to an integer because that's just actual naked stack there. Guess it doesn't help when I point at my screen, does it? Let's see. Oh, at. Yeah, it's just that first column. And that's a column of symbols, the names, and so forth of all of the objects. Let me pause. And where do I get to see you again? Do I have to? Is that it? Yeah, that's it. Wow. Okay. Let me pause and get some feedback. Was that like coherent?
What was the question? Was that coherent? Sort of.
Okay, because I mean, you understand that the I mean, this is you know, abstracted. This is simple APL in a sense, but the creation and destruction of these objects, you know, is the essence. That's but also being able to save the structure to a flat file, you know, particularly when there might be multiple references to a single object. But in any case, that's the names of all of the items that are in here. And for instance, okay, Model T engine specs. I just hit Control C to copy that down here. One of the things is you see that an awful lot of the point of this for me is to be able to just follow my train of thought. Now that's an item obviously in this dictionary R, and to fetch it, VFetch is the name. Ah, wow. Okay, this is reality. That's why I do control. That's why Control S is the most fundamental thing. Where are we? Let me go to this line. We'll go here, and let me see what in the world. Whoops. Happened in trying to. Actually, let me skip that. Let me go to the script 0 because that's more important. And as a matter of fact, I'll also get down to everyday work, you know, sort of the nature of things. Because one of the things is, well, need to get back to this stuff. So I just did a save, by the way, in case, look, yeah, there are the numbers that were pulled up on that. And if I ever get back to, and this was the headings off of them, if I ever get back to that stuff, but I mean, you know, that in a sense is the essence of my motivation in all of this is, you know, want to do some stuff that it may be on any sort of a thing. I was going to have this as my introduction. Okay, we've got the fundamental structure and a bunch of examples of everyday continuous use. So now let me get some feedback. The people understand that in a sense you have an environment which is written in a fourth, which is directly in, here, I keep useful lines around. Oh, and this is one of the most useful. I've just recently renamed this, because any line you have, I mean, you've got a script here, but the thing is that you're just living in your script. So I've recently renamed my help function to question mark. And what question mark does, oh, and well, what it does is there's a list of files, of source files, of all the source files for Fourth Cozy. Whoops, didn't mean to do that. Oh, let me get back to where I was. First, let me get you guys. And then that's me. I got too many windows here. Actually, there's a better way to get it. Whoops.
Lunch.
First there, and oh, something happened. Something happened. I didn't. Where are we again? Yeah, what did I was going, well, I was showing you any word, actually a good one to do would be question mark, but it goes through all the source files and it grabs all sections. This is from file derived, and it grabs any place that the phrase occurs, plus anything that has a connected by a non-blank line. So here, actually, where the cursor went, you can see there is a space on that line. So spaces on the line stick things together. But I found that, but it'll learn any sense of the thing. So essentially, it's when you write something, you decide what'll come up, when, you know, for help on it. So, oh, and let me go back to actually, yeah, go back to the things. There's a variable here, sys. Yeah, let me come down here. Actually, because getting things from the root is so common, there's a shortcut RV fetch. Why is that? This has happened once before. Let me go over here. That's why. Goes through this list source. That's weird. I don't know what's happening there. In any case, let's see. I'll have to see what the hell happened on that. I don't get that. Let's see. So we've gotten through one of the things I should go and say. The Riva fourth that is underneath there and is the help for that is the word help, and this is one of these recent words that simplify things a lot, because anything that produces a oh no, for a moment. Oh, I don't know what is that slow. Yeah, this is anyway the Riva help on all of the raw fourths. Also, C is of course that's C the word CSS to see the definition and so forth. So those are your fundamental help words, and then there's some more. Sort of hit on script 0 being loaded and so forth at the beginning, but that's about everything. My question is, how do I go and make it as seductive as I can, as an environment in which to just have a fourth notebook that has an APL level language which the interface itself is in.
Okay, there we got a mic. Okay, our mic.
That's
it goes in and out. But you've caught us all speechless.
Is it that far out still? I mean, in a sense, that's the thing about it definitely is bringing together a two ends of well, again, you know, to me, the two great minds have been Iverson and Moore, because they represent the two ends from having a notation to express a thread, and actually implementing it in the machine, and that's one of the things is you know, I almost see it as being a notation to get through this bottleneck of expressing a thread that then can get spread out to whatever array of computing, you know, this is the thing. Yeah, again, I think that's certainly the fourth end of things. That certainly has been my motivation to take it, to go from this life in APL level notation. And as a matter of fact, actually, one of the kind of interesting sorts of things in this, where's script 0? Oh, the real change, the trivial change that made things so much simpler is that to be pure, the input for a string is S colon and string, and S in front of a colon makes it, reads in a string. And to be pure, I output it that way. So if I put a string like whoops, you also see that it has to be pretty trivial for me to be able to make any. I need the backspace key. To make a string, it should output the way it inputs. It should be an invertible thing, and I've not done all of those making everything invertible yet. But I always did for years essentially. I went and did that, but then I decided, hey, this is a pain, and so it's impure, but these scripts are just strings, and I eliminated that on the output, but that makes it so that I can just trivially go. You don't have to go into and execute things with a shift F6. You don't have to execute things as raw fourth. So it becomes really trivial to go and keep track of notes and a couple of the keys that I've got. I don't allow execution in here, but then again, it's sort of one step at a time. Lots of people could take this, but it's funny that one of the things that's in here in the script, because it came up on other things, is the Stefan Boltzmann transitions back and forth from power to temperature. And also, and I can't remember, I don't know whether, I can see anyway from my notes that was back in April. But in some blog conversation, the derivative came up, and so I pulled that up and translated it into fourth cozy as it currently stands. Note, by the way, one of the things that is, because these numbers are going directly on the stack, or in this case into the floating point stack, I have to go and turn those into cozy objects with either this form, or I think it probably is useful to scroll up to this stuff that's at the top. And the help stuff, there's a list of all the forms. This is very in the style of Arthur Whitney. I'm far less cryptic than Arthur Whitney, which is a painful thing to say, but you can see, you can specify an integer vector with putting the I around it, or a floating point vector. All of this eventually should be made. Or if you've got a single underline I, we'll go and turn it, take it off the stack and put it as a cozy list, one item list, back on the stack. So one of the things you can always safely do, if you have if you have some garbage row, that's too garbagey a number on the stack. If I just hit F6 right now, that's it try to access location 234. But if I end it if I convert it to an integer, if I don't know what's, oh, by the way, should point out, the stack is always shown here, and generally what I'd call a sentence is something that goes from a stack being empty to empty. But in any case, underline I'll always turn it into a vector and make it safe. So if you question about some line you write down, if you think, well, yeah, you can underflow the stack. Anyway, once again, let me stop, because there's I got to do something else and just go on with this. It's how do I get, yeah.
Feedback from my point of view is what it looks like you've been doing there is what I remember back to mind maps.
To what?
To mind maps.
Oh.
And, that type of thing where there was an effort a couple years back on mind applications where
was that an Apple thing?
What was that?
Was that an Apple thing?
I don't remember that Apple ever did it.
Oh.
No. But I knew a couple applications that were doing these ways of putting information, just mind dumps that you could reorganize and that type of thing. And that's similar to what you're doing is basically a memory amplification.
Absolutely, in some sense. I mean, but one of the things is, and this is, again, there's so much of this, these screens look very little different than they did when I first had wrote the first, you can find images of this going, back to the mid 80s when I was pulled down to Manhattan by a guy named Marvin Markowitz, who essentially funded the first. It was multi-windowed. I mean, before Windows, and that was actually the trick. And actually, that's one of the things that lacking here. That I think that if you just actually look on here, let me go to. Just click. All of these are well, essentially it counts. And I wanted to go to the top level. Actually, let me. This is today's bank accounts and so forth. This is all in K-Cozy, but let me go. Here's Cozy itself. But actually, let me show you this, because this is more the mature sort of structure of sort of where I want to get back to. One of the things is to have a grid interface, so you can have things like, well, here, this is, I actually, and I've done this for years, actually even keep track of my cache outlays, but I need a grid interface. The language can express it, but you need a grid like K has, and this was a really, I think, created at Morgan Stanley, a so-called electric interface, but I think it's relatively common now. And I know people, interface Excel with K all the time, so that's why this never went anywhere. But one of the most fundamental things is the structure. I only have two windows over here. I have a text window and I've got a result window. And by the way, you might have noticed that there's the last line executed is up at the top. You may not be able to read that little stuff. But here, most fundamentally, well, I've got the last line executed and so forth, but actually I'll execute this this line and so forth. But I've got a sort of a, well, it's called here state window. Let me make it smaller, 10, so that it shows this is the text window, and this is all sort of a time-stamped log of the things that are going on. I call these units a job, which actually was back in the mid 80s, calling something a job had a certain amount of, I mean, it was in honor of, but in any case, that's sort of the long range get back to sort of things, because this is actually the thing that's most why APL's market is financial applications, because at some point in your life you got to take care of accounts and so forth. But and I just have always had computing resources more than anything else. But the real notion here is electric paper, so that the rearranging of things is it just comes from the fact that you've got paper. But if you write something down the computer can do, and you hit F6, it does it, whatever it is, and that's in language which is as fundamental as it can be. Well, I know this is far off, but it really is, obviously, I think that in a sense, what I'd like to put is first, if you just download it and let me know if it actually runs on your machine, and then start writing down some forth, even, because this is the thing. I mean, one of the things in choosing this Riva forth, it had to be in a chip language for it to be of any point to me, for me. It's making that connection all the way from the chip language up to this APL world of dynamically created and destroyed. I mean, created and destroyed thousands and thousands of objects, and I'm just astounded that I got it right. I don't know what else. I'd really. What is the best way to distribute things? Why should I? Would a Git be worthwhile? Actually, that's the thing. It's what's most fundamental is to get, some other heads that can sort of span this and you guys are definitely some of the prime candidates and so forth.
Well, convincing any of us do anything on any other floor is interesting to accomplish. The Forest programmers tend to be lone wolves, but there is a up on GitHub. Is it Fourth Star? There's a bunch of fourth areas up on GitHub that are getting a modest amount of traction. I don't think any 1/4 is gaining a lot of popularity right now, and you seem to be off on even a farther tangent than fourth is, which
Well, except that
yell to it.
you're both, you know, the thing is, and in some ways, there is this threshold that it has not crossed. That in fact, and here, you know, perhaps I should, you know, 1, 2 minus dot. If I'm holding down the shift key now, you can't see that, but this is shift F6, and so this is a fourth. And if you want to, if you will, play with fourth concepts and so forth, this allows you to go and remember what you're doing, you know, for one thing. I mean, it is just sort of an interface that, like somebody else's interface to a fourth, like, what's his name, Stephen Pelk. I bought any of the interfaces to a fourth, except this one is an APL one, and it's all open code all the way, everything, you know. So, I mean, I see that just as here, you want to learn fourth, here's a very sophisticated environment for learning fourth. But also, and I see long range, what I want to see is these core algorithms, the lists of list structures, and the headers for all of the, you know, for all of the for any cozy item is just 4 cells, a length or a type, a length, a one that's split between reference counts and number of bits if it's a fixed thing, and then a meta, which is a link to any meta information that may go along with an object. So I mean, it definitely is something where you have at that end of things a structure that can be translated to any fourth, and without question. I mean, that's without, you know, somebody who'd be interested to translate it over to an ARM and simplify it tremendously in the process is of interest.
Yeah, it's just convincing anyone to follow you has been problematic in this anything involved that isn't IoT or something like that in standard language that isn't JavaScript, and there's a lot of activity on doing all of those, but doing it for Forth or APL or any of these maps all died, and
this is as extreme. I mean, there's no question. It's as extreme as there can be. I've sort of, but at the same time, there's an incredible practicality to it. So I see Stacy. You're hanging out. I happened to. This is over in my notes. I was thinking about things, and this. Whoa, that's why I need backspace. I noticed that one of the very first early notes that I made was, boy, this is way back when it was trivial to go and do this. So this is in a sense the first. But that's the total notes I had about you. But this is the thing, is around the world. I mean, you know, in a sense, if it's you can go less, and okay, I've updated my notes and so forth, you know, on that. So you know, definitely it's for that sort of an interface for life, you know, with, and so I actually think that one of the most profound things, of course, in general, is symmetry breaking. An artist that I really liked, Ed Herman, actually, in New York, had a party that he had gotten a grant to do some art thing. And so what he went and spent his grant on was a whole lot of Budweiser. And he went and stacked it in a very crystalline fashion in one corner of the room as his piece of art. And people would come by, and of course they wanted a beer, but it was like, you know, until the first one broke the symmetry and actually went and took a beer, which was, of course, Ed's point in the whole thing. Getting symmetry broken is a very major thing, and but as soon as it happens, I'm you know, this is hell with it. It sort of is my you know, party here. Let me go. Yeah. Of these things, this guy Christopher Zeman, I just wanted to mention, he just died this year, but he brought catastrophe theory into the English language. And I don't know, it definitely is Renee Tom stuff. And you heard about chaos theory and all of that. I did back my first uses of APL, and then essentially what forced me on this path was in visual psychophysics. I went and expressed stuff. I could write a Fourier transform in one line, a definitional Fourier transform in one line. And all of this is on Cozy if you wander into the right sections. But I had Christopher Zeman was visiting, giving a talk. And actually, he invited me out for lunch. And it was some of his notions describing the brain or the motion of thought, of consciousness or whatever, as being a point moving in a, you know, what, 10 to the, well, tera, whatever, giga, or petadimensional space in a cube, in a petadimensional cube. Was very, because that's why I learned APL and all of that. But I've been ostracized all the way over to you guys. So
Oh, that's good to hear. Where did we live? There we've got the mic. That's good to hear.
Yeah, you're you know, how much further can I, you know, I mean, actually, you know, one of the things that I got back, I realized, and Chuck is so much mapping arrays to arrays, you know, I mean, arrays in silicon, and so there's, I mean, this is as far as you can go. It will. I mean, in a sense, one of the things I find interesting is you guys don't discuss fourth per se as much as you discuss architecture itself. I mean, the arrays that you're going to lay down in the silicon, and the dimensionality of it. I mean, man, you know, it's all the way from that other end, that end where the action is in the high frequency trading and so forth, because if you're really good at number crunching, no matter what you'd really, druthers are, the ones that have the most immediate return are ones that have currency symbols attached. So I don't know. I guess this definitely is. I think has become actually the only thing is that y'all should have beer, and I should have some Colorado specialty Teller County. Except maybe the whole problem with my life is I've had too much of that all along and didn't care whether people were following me or not. But,
I think that's common within the fourth.
I'm sorry, that got all staticky.
I think that's common within the fourth industry that many of us don't care if anybody follows us.
Absolutely. Absolutely. I mean, man.
That was Chuck's attitude also, is he didn't care if anybody followed him.
Chuck, you're saying, yeah, no question about that. But one of the things is he's overall been more successful. I mean, I've been astounded how successful he has been in actually having people, pay him for what he, anything for what he wanted to do. It's extreme. And it continues with things like green arrays but he's never bowed to the power of two.
Well, for a long time he didn't need to. He was making enough patent money that he could do IntelliSys and grain arrays.
In a sense, one of the things in my sort of looking at arrays to arrays is looking at the simplicity of the structure of the Novix chip and things like that. I mean, it just you can see here, you're going and taking this bunch of notation, and the thing is, on the APL end of things, the notation is an array notation. So you're taking these conceptual arrays and mapping them into silicon arrays, and so, well, I don't know. I sort of hope. I hope you'll invite me back sometime. Because at the second half of this, I mean, my God, you can imagine. Look at how many of you can get together in a room, and I'm here. I mean, Colorado Springs is not bad, but it ain't Manhattan. You guys are Manhattan.
Well, and I'm still having trouble getting this microphone to work.
Yeah, it's kind of noisy.
This is Kevin, and consider yourself re-invited.
Yeah, well, but boy, hey, anybody go and give me any feedback on the page there, and say, damn, didn't get past the virus filter, it's getting a conversation going.
Yep, and we're my mic is not coming through.
Well, there are only a couple of hundred in the entire world that are interested.
Yep, and we have about a dozen people every month, and we keep showing up.
Yeah. No, it's.
Is there a quick place to download it from?
Can you put up onto the screen where to download your stuff from?
Oh, just go to cozy.com, and you'll. I've been restructuring that a lot to go and de-emphasize all of the various other things, other than to some extent the planetary temperature thing. And incidentally, it's absolutely just having a computational environment like this at my fingertips that caused me to get so involved in this war on the goddamn molecular basis of life. I mean, it's so corrupt, and it was so great to see Brexit. You know, yesterday. Oh, I tweeted Christopher Monckton of Brenchley has a really fantastic article on the meaning, the historic meaning of Brexit. And he's one of the people that I know from Harvard conferences. So I recommend, yeah, follow me on Twitter.
Okay. Well, put up your Twitter address then. If you want.
Oh, everything. Just click cozy.com and everything's on the front page.
Okay. Okay, will do.
Yeah. Great. Great. Thanks, Kevin. You know, I like your humor, so. Bye-bye.
Okay. Thank you very much.
Turn off my mic. If I can find the thing.
That was it.
Why don't you? I'll mute.
Yes, he's still there. No, he's not. Well, he's not talking.
I'm muted. I'll unmute if you saying
So
something.
Bob, it was a question. I was just talking.
Oh, okay.
Oh, okay.
You're over here.
Yeah,
What?
Bob. So I was just chatting
Yes.
with Dr. Ting. We were talking a little bit over lunch.
What?
Dr.
Can you
Ting.
speak up?
Yes. Can you hear me? Can you hear me?
What is that? A boom mic?
Yeah, it's the mic is not working. Up there it goes. Now.
I'm in a big. It's not a mic. You need a support to hold. It's like-
Now, no.
Whoa.
Dave's gonna have to work on this connection again.
I was getting it. Just
We can barely get
Where's the
anything through here, Bob. So we're probably going to call the end to this because I've got to sit here and hold it very delicately before we're getting any bars at all.
yeah, it is. It is. Yeah, Stacy. Drop me a note on Cozy.
Yep. So we'll
Break the ice. Take the bud.
Yeah, I'm not getting much of anything through here. And I don't know why, but it's not working now.
Well,
It was working earlier today.
I'm getting a lot of static. It's like there's a bad connector somewhere along the chain.
Yep, and I'm touching.
But now it's not much of sound at all.
Yeah, it's because it's just lost. I'm not getting anything out, so we're gonna have to call quits. Yeah, there's nothing left. It's gone. Okay. Well, thank you very much.
What? I can't hear him.
I know.
That sign language? No, totally dead.
We're dead.
Okay. Bye-bye. I guess if I hit that, what happens? Okay. Oh. Yeah, you've been seeing me, I think. Anyway.
We can't talk back. Oh, there's
Oh.
a little bit.
Oh. Yeah, I don't know. I take it all the time I'm sharing screen. Oh, you're seeing my screen. You haven't been seeing me. Oh, there's the 6 cube, which is from a 4010. I got to say, it's fantastic to see. I don't know, you guys talk about such interesting stuff. Perhaps it's just age. But
We'll give up. See you later. See you next time.
okay, auf Wiedersehen.